everyone, this is Aurora with Supercharged Science, and we are going to be doing a class in electricity and electronics. Now, if you are just joining us for the first time, my name is Aurora. I'm with Supercharged Science, and we are going to be doing a class in electricity, and we're going to make burglar alarms today. And actually, I had a picture of the electric eye here. Did you see that? We're actually going to be making this ourselves. You see there's a little sensor right here, and if I cover it up, and I completely cover it up, the light almost goes out. But if I let it open to ambient light, so the light just in the room, it allows the current to go through to light up this light that you see here. And if I shine a flashlight on it, it glows even brighter. What if I shine a laser on it? You think that would actually make it go brighter? You think it depends on the color of the laser? So we're going to do that and more today. Now, if this is your first time joining me for a class, I want to extend a special welcome to you. My name is Aurora with Supercharged Science, and we're going to do our shouts out to kids. So if you want to just type in your name and where you're from, if you're out of the United States, go ahead and tell me what country you're from as well, so I can give a quick hello to everyone. Now, I don't get to everyone. I've probably figured that out by now, simply because there's so many people that are on, and so also so many people that watch this after it's live as well. So I want to extend a special welcome to them as well, those of our friends who can't join us during the live time, either because they're sleeping right now or maybe they're involved in other things. But make sure you do take this video and you share it with as many people as possible. All right, so I just giving you a chance to type things in. Let me just reiterate the free stuff Supercharged Science has. We've been doing science classes and workshops in physics and chemistry, biology, earth science, and more since 1999. So that's over 20 years. So we're pretty good at this. And I want to show you some of the things that we've put together just for you that are free that you can access. Now, the first one is, of course, our Facebook Live page, which you can access. We're doing regular Facebook Lives every day and you can see I'm right there. And so we are doing free Facebook Lives classes at 10 a.m. Pacific, Monday through Friday. And you can access any of these videos afterwards simply by going to the videos tab right here, and those are available and you can watch any of these. There are ones on aviation, there's one on physics, you name it, it's in there. The second thing is we put together a school. So superchargedschool.com will get you to this website. There is about a month's worth of content in here that you can use with your kids, and you can use it everything from math and multiplication tables to nutrition to reading to writing to science. And so all of that is in here. It's at superchargedschool.com. The third one is if you go to superchargedscience.com/robot, R-O-B-O-T, you can sign up for a build your own robot. And those of you who have the materials for today, you have what you need for this robot class. Just sign up. You have the wires, the motors, the clothespin, you've got it. And so you can simply follow up today's class with a robot class. And so that one's free. You have to sign up for that one because I'm going to email you a worksheet that goes with it. So you can sign up for that. That's superchargedscience.com/robot. The fourth class is superchargedscience.com/class. C-L-A-S-S. That's our marine biology class. That's super popular. It was only going to run for a week, but it's actually been running for several weeks now because so many people have been calling saying, wait, we didn't get to participate. So that one's ongoing. So if you've already done that one, then hop on over to the robot class. Okay, so and this little link at the bottom, that's if you want me to teach your kids science all the time, all day long, keep them happily engaged and excited. Kids ages K or grades K all the way up to 12th grade. You can learn more about how we do that there at superchargedscience.com/school. You guys ready for your hellos? Okay, here we go. Who's the first one? Emma was first here from Houston, Texas. Hello, Emma. And we have Tammy and Hunter from Idaho. Welcome. We also have Kristen and Elisha from India, Idaho, India. We actually do have somebody from India. We have Danish. Hello, Danish from India. We also have Sullivan and Sawyer from Maine. Welcome, good morning. Hello from Oregon to Brooke. We have Emma and is from Texas. We have Vancouver Island, BC, Canada. This is where it gets hard because everybody's typing in right now and it's going crazy. We also have a number of people that email in their hellos, so let's not forget them as well. We have Sylvia from the Philippines with her family. We also have Matish from, it looks like New York City. And we also have, back in the comments, we have have Darcy from New Mexico and the family from Michigan. Oh, they just zoomed by. I couldn't find them. We have a bunch of people from Florida. So Naomi and Sebastian and Kelly and Helen and Heather. Different families. Those are 5 different people. And so hello to everyone. You guys ready to get started? If you are, say, oh yeah. Okay, so for today's class, we are going to be building on the content that we talked about yesterday. So if you missed yesterday, don't worry. You can simply access the videos. Remember, I showed you how to do that over here on Facebook. You simply go to where it says videos, you click on it, and it will have the latest videos. And this is actually the one from yesterday. So you can watch that anytime. Now, we just covered the concepts about how to hook up a basic circuit, but if you're just joining us, don't worry. You can still do the burglar alarms today. I do encourage you to go back to yesterday's as well, because tomorrow's is going to build on even more. We've got relays to do, DC motors to do. We've also got nerve testers, and we're going to build a radio at the end of the week, a radio that really works. So, are you ready? Okay, so here's what we're going to do. Now, yesterday we talked about content. We did the principles. I drew diagrams about water flowing. We talked about current and charge. Now we're actually going to take that knowledge and we're just going to start building. I have 3 different burglar alarms I'm going to show you how to make. 2 of them I've already recorded up on video. And I'm going to show them the video to you. I'm going to stop and start the video as well because I've made some changes since then. So, because there's a couple of different ways you can make these burglar alarms. So why are we making burglar alarms at all? Well, if you're in a family, you know you've got some personal stuff, and it's kind of important to protect them, right? Especially if you have siblings that are really inquisitive. So wouldn't it be nice to be able to protect your stuff, or at least know when your lunchbox is being opened or your secret stash is being opened? Okay, so we're going to be making a tripwire, which is just like it sounds. When somebody trips, it's going to trigger the thing to go off. Whatever goes off is up to you. I'll show you that in a second. We're also going to make a pressure sensor. So this one is really great. You can slip it under a mat. Wouldn't it be nice to know if your mom is heading down the hallway? You know, like she's really good, just like you are, at sneaking around. And she can walk down the hallway without you even knowing. You can actually put this under a rug before your door, and as the weight of her foot and her body weight will trigger the alarm that could be wired, say, inside your room. It may be trigger a silent alarm, like a light bulb, so you know she's headed your way. You better put away your flashlight and your book and pretend to go to sleep. Okay, the third one is an electric eye. And that was the one I was showing at the beginning of the class. So we have a lot to do. You ready? Okay, so here we go. Rub your hands together. Pretend like you're about to get a gift, like you just are so excited about this one. Say, oh yeah. All right. And now I've actually set up a little table over here so I can do this for you real time as well. So the first one is going to be a tripwire. And for a tripwire to work, it needs a couple of things. So don't do this yet, just watch me. If you don't have any materials at all, I forgot to mention this, just grab a piece of paper and grab a pencil and either write some notes or draw a picture of what I'm doing. So when class is over, you can rummage around and find the materials that you need just using the stuff that you've got lying around the house or in the garage. Okay, so a regular piece of paper and a clothespin. Now, imagine this paper is a lot smaller. I made it bigger so you can see it. And if we punch a hole here and put a string through it and we run that string across, it could be a piece of thread, something really invisible. We run that string across. When somebody walks, they can simply, when somebody walks through, it'd be like a runner at the finish line, right? They break that finish line. They're going to pull on that string, and then this will release. This will pull out of the jaws of the clothespin. Why is that important? Because this clothespin we're going to convert into a switch. Now, most switches that you use, for example, switches could look like this, switches can look like knife switches. They're all different kinds of switches, and we're going to be dealing with these today. This is a type of switch, whoops, it's a potentiometer, it's a dimmer, so it'll change the brightness of the light. I have more, here we go. Typically when people think of switches, they think of switches like this. You know, it's either on or it's off, right? Okay, so here, let me get my screen ready for you. Here we go. It's either on or it's off, right? Okay, so, hang on, sorry, sidetracked. Okay, so it's either on or off, right? Okay, so typically, this will be one kind of switch. This is called single pole, single throw. That means, so when the switch is in this direction, it doesn't have like a center off. It's either on or off. So when the paddle is down like this, these two are connected on top. When the paddle is up like this, the two on the bottom are connected, okay? So keeping that in mind, so it's just like flipping a switch, you can have your circuit come in and come out of the center and then come in and come out. So this switch could turn on, say, a motor when it's in this position or a light bulb in this position, depending on how you hook it up. Okay, so some switches are, I'm looking for one and I'm not seeing it. Here we go. Some switches are here we go. This is the one. I can't believe I didn't see something this big. Does this look familiar? Old arcade games. This is the button from an arcade game. Right? This switch down here, I have a bigger version of it, is one of these. Okay, and so we can switch it, and the different tabs for connecting are on the bottom. So every time I hit the button, it engages two parts of the switch, and when the button's not pushed, it engages two other parts. Okay, so this particular switch is called normally open. So if you leave it alone, the circuit is going to be open. Nothing's going to happen. This particular switch is actually a momentary on, but just pretend it's a normally open, like this one. So this one only has two tabs on the end. Do you see it? So in our circuit, just like with the one we made yesterday, this is an index card. So the electricity is going to go in, but if there's nothing connecting the two sides, it's just going to be normally open. It won't actually, it's like that pipe that we talked about with the water. We busted open the pipe, and now it's not a closed circuit, and nothing's going to happen. So this is a normally open switch, and it's only when you close it that something happens. So we call those NO switches. Today's switch is an NC switch, normally closed. That means when you leave it alone, electricity is going to flow through it, but when you do something, that means that will stop the flow of electricity. It makes sense? They both have their applications, but it's important that you understand the difference. So what we're going to do is we're going to turn this into a switch, and I'm going to show you one way to do it, then I'm going to turn to the video that I recorded a second way to do it. So either way will work. So the idea is that we want to cover the jaws of my clothespin here with something that is electrically conductive. Now, tin foil is great. It's cheap. Most people already have it. And all you do is you open up your jaws and you simply squish it on like that, okay? And you got to make sure it's not going to touch until the jaws close. Does that make sense? Just like that, okay? So now the switch is on, electricity can flow, but if I were to open this, now electricity would stop here. There's no way for it to bridge that gap. If I put a piece of paper in here and I close it, is there any way for it to bridge the gap? And there isn't. Unless I put holes through the paper, right? So this is an NC switch, and right now it's open, even though it looks like it's closed because I'm not squeezing it, or I'm not just leaving it alone. Okay, does that make sense? Okay, so here's what we're going to do. We're going to build a tripwire. So you can either do your clothespin with the foil or using the tacks like I'm going to show you, because sometimes the foil can actually yank off. So use a little piece of hot glue in there or something, or tape. Just make sure you can get it to stick. Okay, ready? Okay, let's go transfer to the video so you can see what I'm talking about. Okay, the things you're going to need are a clothespin. You're going to need that long piece of steel wire. You're going to need 2 tacks, and you're going to need your battery pack and a light bulb of your choice. Okay, so the first thing you need to do is prepare the burglar alarm. This is going to be a tripwire, and the basic idea is that when someone trips over something, this alarm will fire and a light will go on. You can replace the light with a buzzer if you want. You can get buzzers real cheap for a couple dollars at Radioshack. Make sure you get a buzzer that's 2 to 3 volts, because that's how many volts you have in here. Each battery is 1.5 volts. Multiply it by 2, you have 3 volts available. The first thing you need to do is take your steel wire and cut it in half. You only need a little bit of steel wire for this project. And you're going to take the very end of the steel wire. I'll show it on white here so you can see a little better. And the stem of the tack is where you want to wrap just the end, a couple of turns around. So you want to take the stem, I know this is real small to see, so I'll talk you through it, and just wrap the steel wire around a couple of turns. You just want to make sure it doesn't come off. Okay, so you've made something like this. Steel wire with a tack at the end. You want to do this 2 times. So take your other end, wrap it around and around. Okay, until it doesn't come off. Okay, so you've got 2 of these. Now here's the hard part. You have to stick them on the inside jaws. So if this was an alligator and his mouth is closed now and his mouth is open now, you got to stick these on the inside. So with it open, go ahead and push in your alligator clip into the jaws, the tack. And to get it to go all the way through, I'll usually push it closed. Okay, so I've got one. And make sure these wires stick out in opposite directions. So I have one wire sticking out this way. I'm going to put the one on the top jaw sticking out this way. Just an extra precaution so they don't touch and melt your batteries. Okay. So I have my steel wire, one coming out of each side, and I can open and close, and now it looks like my alligator has braces. He's got teeth on the bottom, metal teeth on the top. Okay, so that's what we're going for. All right, now you need a small index card of some kind, and I'm just going to cut a small piece from my green sheet of paper here. Doesn't have to be big. And I'm going to insert this here. Okay, and the idea is that you punch a hole here and you tie some string, and you put it low to the ground, and you can tuck this into a corner. And you have a small piece of like fishing line or thin thread, and when somebody trips over it, it pulls this out. The switch is now closed, conducts electricity from the tacks, and the light or the buzzer goes on. So I'll show you how to hook this up. The first thing you're going to need is your light bulb. Now hook your light bulb into your battery pack here and make sure it works. Make sure you've got the light bulb in the right way. Okay. Now you're going to add that third wire just like we did for conductivity testers, and you can test it. You can touch the metal part and see, yes, the light still goes on. Now this part, you're going to add this switch. This is the tripwire. This is the burglar alarm component. And the idea again is that you hide this in a corner, you put string here, and when somebody trips over it, it pulls this out and the light goes on, and you know somebody's here. This one's really great if you put a buzzer here, because the person suddenly hears the buzzer, but it's too late for him to figure out where it is or how to turn it off. Okay? You didn't hear any of that, did you? Oh, so sorry about that. Okay, let's try it again. Did that make sense? Did you see how what we were doing here? Let me put it back on. Did you see how we were just connecting to the foil itself? Did you see that with the clothespin? That's all we were doing. The next one is the sandwich. Now, this is a sponge. This is electrically conductive tape. My sponge happens to be black. Your sponge can be any color you want. You might probably want to get like a green, or not a green one. You probably want to get a clean one from your mom. And so we're going to be using a sponge to do this experiment. Now it's really simple. If you don't have any materials, just write down the picture of what we're doing. So there are going to be 5 layers to this sandwich. We're going to be building a sandwich, and then we're going to wrap the thing with tape. Just take notes of what the different layers are, and that'll make it a lot easier to do. Okay. So here we go. You ready? All right. So let's take a look. To make a pressure sensor, you're going to need your battery pack and your batteries. You're going to need your alligator clip wires. You're also going to need 2 large paper clips and a pair of scissors, a little bit of aluminum foil, and you can either use a buzzer or an LED, whatever you'd like to sound for your pressure sensor. When it feels pressure, it's either going to light up a light bulb or it could even sound a buzzer. And you're going to need a small piece of foam. Now this piece of foam is kind of thin. Basically, you just need a piece of foam or even a sponge that when you press it, it'll actually pop back into shape when you're done pressing it. So any regular piece of foam will work just fine as long as it's the squishy kind, okay, the kind that squishes back. So sponges tend to work pretty well there. So you need a piece that's about 1.5 inches by 1.5 inches or even 2 inches by 2 inches, okay? All right, let's get started. The first thing you need to do is cut out 2 pieces of foil that are just about as big, as large as the foam piece that you have here. So let's do that first. You can place the foam right on your foil as you cut, just like that. And you actually, to be honest, you want the pieces of foil to be a little smaller than your foam. So if I line this up here, I see that I can't quite see black all the way around, so I'm just going to trim it a little bit more, just like that. And so when I put it on, I can actually see black on all 4 sides. That's what I want to do for both sides of the foam. So I've got one piece that looks great, and I'm going to put my other piece on. And again, it's still too big, so I'm just going to trim it a little. Just like that. Okay, so I've got 2 pieces that are slightly smaller than my piece of foam. The next step is to actually cut a small hole right in the middle of the foam. Now, you got to make sure you do this without putting a hole through your hand. So using your scissors, kind of put a drilling motion in through the foam until you see the scissors come out on the other side. Okay. Once you've got that, you can put your scissors into the foam and cut out a small square. Now, when we do burglar alarms with kids and we make these pressure sensors, this is the single reason that their sensor doesn't work, because their hole is too small. You want to be able to fit your finger, or if you're a kid, you're going to fit 2 fingers through the hole. Okay? So if you're in doubt, if you're not sure if your hole is big enough, go ahead and make it bigger. Otherwise, you'll have to take the whole sensor apart to make a larger hole. Okay? Just like this, so you can actually fit a whole finger through there. Okay, let's put the whole sensor together. Now, you're going to make a sandwich. You're basically going to sandwich your foam between 2 pieces of foil. And again, you want to make sure the foil, you can see the black on all sides of the foil, just like that. Okay, we're also going to put 1 paper clip on each side. I'm going to have this paper clip facing one direction and this other paper clip facing the opposite direction. Okay. So the top one is facing this way and the bottom one's facing the other direction. And I'm going to wrap this whole sandwich up in tape. So I'm going to carefully put that down. Get a large piece of tape. And go all the way around my sandwich. Okay, making sure that I am putting my paper clips one out of each direction of the foam. Just like that. Okay, so I can see my black all the way around, and I have paper clips pointing in opposite directions. Now, how do we hook this up? Your pressure sensor is actually complete. Let me show you how this works. Now, for this example, I'm going to use a buzzer. And before you ever put any new burglar alarms in your circuit, you always want to just connect whatever it is you're going to turn on and off, like the buzzer, in just to make sure you've got it in the right way. So I'm going to hook up my circuit and hook up my buzzer. Alright, and the buzzer works. So I've disconnected my red. So when I connect the red, the buzzer turns on and off. A burglar alarm is basically a switch. And when you engage the burglar alarm, it's actually going to allow electricity to flow. That's all burglar alarms are. So I have my red wire here, and now I'm going to connect these 2 points together. The red wire from my buzzer to the bottom paper clip of my burglar alarm. And I'm going to use a green wire to do that. Okay. My buzzer should not be on because the burglar alarm is not engaged. So here's my battery pack. Electricity goes through the wire, through the burglar alarm, through the green wire, through the buzzer, through the black wire, and back to the battery pack. So it makes a giant circle. Spread yours out so you can see the giant circle, so you make sure that all your connections are just right. Now, here's the idea. You want to step on this. As soon as you step on it, that's why it's called a pressure sensor. You hide this thing underneath a rug or something like that, and when your parents come down the hallway, you know they're coming. So, there's your pressure sensor. Okay, you can hear me now, yes? So what do you think? How was that? Does that sound like something you can build as well? Okay, so we've got one more for you, and this one I'm going to do for you live down here on my bench. So cool, right? You can now totally rig up your room. And can you combine these sensors together? Absolutely. Do you have to use a buzzer? No, you can make them silent so nobody but you knows they've been triggered. You can use lights, or you can hook up sirens to them. It's totally up to you. All right, your parents are probably thinking, oh goodness, are you sure we should be listening to Aurora? Yes, you should, because this is a great time to talk about ethics. Okay, so let's go to down here to my screen, or my desktop here. Do you see it? Hello? Okay. I have a little white buzzer here. This is a tiny buzzer. It's only about 1.5 to 3 volts. And I've got a couple battery packs here I've connected up. I'll show you how to do that in a second. This is a light detector. And what's really cool about this is if I take a flashlight and I shine it on my detector, I've hooked it up in such a way that my buzzer goes off. Isn't that cool? Okay, so how do we do this? Now, do you have to use a buzzer? Absolutely not. We can take the buzzer off, and we can put our LED in. I don't know if I've got my LED in the right way, so let's find out. Let's aim it towards the camera so you can really see when it's on. There we go. LEDs are pretty directional. And I can see it's already not on, so I'm guessing I've got it backwards. This one is not the special bipolar one that I showed you before. Here we go, it's on a little bit. So there is ambient light there's light around that's getting to the sensor. If I were to totally encase it in total darkness, the bottom too is also sensitive. If I were to encase it, you can see the light almost goes completely out. And if I were to release it, this is a sensor that it's called a CDS cell, so for cadmium sulfide. It's what it's made out of. And the more light it receives, the more resistance it has, the more it will resist the charge and put up more and more of a wall. So this is like, you know on your sink how you can adjust here, let me show you my face. You know on the sink how you can adjust the flow of water? The flow isn't usually just on or off, right? You can vary that. And so that's what this sensor is doing. And the way it varies it is it looks at the sunlight. And if there's a lot of sunlight, it puts it all the way down. So it's almost like you're turning off the flow completely. And when it's dark, it will actually open it up and allow flow to happen a lot easier. Okay, so if I shine a flashlight, now we have a lot of sunlight, or oh, I'm sorry, we've got this backwards. So this CDS cell is hooked up. You can hook it up the way I just described, but this one is hooked up where the more light there is, the more flow it's allowing to happen. Okay, so how do you hook this up? And notice I've got 2 batteries over here too. Okay. So how do we do this? We had a number of questions about that yesterday. People asking, how do I hook up more than 1 battery pack? So let's take it from the top. So we're going to unplug everything. And by the way, I did talk to you about the kinds of batteries that you want to use. So if you are using the cheap dollar store batteries, the kinds that are usually included in toys and so forth, they'll usually say like carbon zinc on them or super heavy duty. That sounds impressive. It just means there's no acid inside. If you were to take one of these apart, please don't do that. But if you were, you'll find a carbon rod inside and a whole bunch of zinc on the inside, zinc powder and stuff, mixed with a binder. And it basically, I wonder if I've even got mine. Okay, I have mine No, I don't have mine here. I had a battery that was taken apart years ago, but apparently I don't have it. So anyway, so inside there's no acid. These have acid inside, which means you'll also get a higher voltage out of these. So for example, if we were to hook them up, but we hook them up wrong, where we put the electricity back inside of itself, if I were to do something like this and hook this up together, these batteries would get really, really hot really, really quickly. So, so we recommend we don't recommend using alkaline batteries to kids because we expect them to short circuit things and make mistakes. So it's part of the learning process. So you'll want to get them some inexpensive batteries. If this is all you've got, that's fine. Just keep a hand on it every so often and see, it's like, oh, is that getting warm? Is that getting warm? Just to kind of check and make sure. Okay, so how do you hook things up? If you want, each battery is worth 1.5 volts, right? So if you've got 2, how many is that? How many volts do you have? Yeah, it would be 3 volts. Now, depending on how you hook these up, you can either get 3 volts or you can get 6 volts. So all you do is here, okay? So if you want to get 6 volts, which is usually what kids want, you're simply going to take a wire. Now, by the way, if you've got a number of wires and you don't know which one's plus and minus, the lighter one is usually positive. So in this case, red. So the lighter one's positive. We're just going to hook it to the black. Do you see that? Okay, so we're just going to connect the red with the black. I'll push this over. And now for the red, I'll actually hook up a red. And it does not matter what color your wires are, but just to be consistent. Okay, and to the black, I'll connect a black. Okay, now, okay, so I'll put this white one over there. Anything I put between these two will have 6 volts. Does that make sense? We just hooked this up in series. Okay, and so the electricity is going to race around kind of in this pattern. Okay, so if I put a motor here and I hook up a motor and I were to touch the tabs, you would see this motor really takes off. Now, if this motor is spinning the wrong direction, all you do is you flip the direction that the wires are attached. Okay, and you'll see it now goes in the opposite direction. Okay. Notice that it's going to go a lot faster than if we just had 3 volts. Okay, so that was one question that was answered. So how do we hook up this light? Now, you'd only need 1 battery pack for this one that we're doing. So let me just take one off. Okay, all right. So for this one, for the electric eye, you're just going to need your CDS cell and a light bulb. Okay, you're not going to be able to power a motor with this one because the motor draws too much current. This guy is going to take too much of the current. So what does that mean? That means we're just going to hook it up like this. Okay, we're just going to hook these up. I'm simply going to grab onto this guy and then use another wire to connect the other two. Now, if you're just watching and you don't have any materials, just draw a picture of what you're seeing. Okay, and that's all. That's all there is to it. So all we're going to do is hook these up so our circuit makes a big circle, just like that. Now, if you want to see if this is actually, I don't know if I've got my LED in correctly, so I can remove this and just tap it, and I notice the LED does not light up. That tells me that I've put my LED in backwards. For those of you who have a bipolar LED, it's actually 2 in 1 and they're reversed. So you should have a light in either direction, but they'll be different colors. Okay, all right, so it's on just a teeny weeny bit. Now it's pretty much off. Okay, so if we take our sensor and we apply a light to it, okay, do you see how it got a lot brighter? Dimmer, brighter, dimmer. And we can also use, this is the part that really makes an electric eye, we can also use a laser pointer. And if I have a laser beam, okay, now the light is on, but if somebody steps between the beam and the sensor, now the light is off. So this is an electric eye. Where have you seen these before in real life? I'll give you a hint. You ever gone into a store and it's gone, it's really annoying, right? Especially if you're the clerk. Okay, same idea. That's an electric eye. Theirs is a little more complicated, a little more complex, but it's the same idea. Now you can use this and keep it out of the visible range because you can get a detector that uses, for example, ultraviolet or a frequency that you can't normally detect with your regular eyes. Just like the remote control, you can't see a beam that goes from the remote control to the television, right? So, but there's still a light beam that's coming out of there. It's just in a different frequency that our eyes aren't aren't able to detect. So that's another example of a type of electric eye, so a type of a way that a signal is being transmitted and picked up on the other side. Okay, so how was that? Did you guys like this so far? Okay, so you have 3 different burglar alarms. We're getting questions saying, can we talk about batteries? Tell you what is Radioshack? Oh no. Sadly, when this video was made, Radioshack was still in existence. It was like the best place to get electronic components. Here, you guys want to see what's in my toy box? We had a couple of people ask how many sensors I had and how many switches I have. This is just one little box. So as you go through the years, now that you are well on your way to being an engineer and a scientist, as things break, I would encourage you to take them apart, as long as it's safe to do so. Ask your parents, and take apart old toys, and you'll start to salvage pieces like switches and motors. Here, what else is in here? And wires. We got all, these are relays. I think this was from a refrigerator. This was from a video game, and switches. This was from an old pickup truck. And you'll get speakers, you'll get all kinds of interesting bits. This is a knife switch I showed you earlier. We're going to use this on Friday. This is a crystal earphone. But there's a lot of cool things you can pick up. This is a light bulb that we could use instead of an LED. This is a tiny, tiny baby light bulb. It's like a baby one of, where's the big one? Here we go, a baby one of these. Okay. So there's a lot of cool things that you will start to collect, and everybody's collection is different. So I encourage you, when things start to break and your parents are going to toss them, say, whoa, 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 can I take that apart? And you'll be able to salvage motors and wires and batteries and battery packs and propellers and switches and all kinds of interesting things that are in there. Old printers are great for this. Old electronic toys that kids no longer use. Old cell phones have tiny, tiny little, I don't know if I've got one here, but they've got these, oh yes, actually I do. They have these tiny little motors. Here, let me put it down here so you can see it better. They're called eccentric drive motors. They've got these teeny little motors, and you can actually make solar-powered robots with them, which is what I've done here. For those of you who are in our online eScience membership program, this is in Unit 14, how you can make solar-powered mini type of robots. This one goes inside of a ball, and he just rolls around, and that rolling in, when he'll charge, and then after he's done charging, he'll go, and then the ball will roll. It's like having a little hamster, but it's electronic and it goes on its own. So anyway, so that's in there as well. So anyway, so you can start to salvage and make your own little box of fun stuff that you can pull out and play with. So I hope this has been helpful for those of you that are wanting to do even more. If you want to learn more about I can talk about batteries tomorrow in addition. Tomorrow would be a great day to do it because we're going to be making motors from scratch. So if you have your magnet wire, you're all set. If you don't have any materials, just stick with us. It's really easy. You'll be able to baffle most grown-ups, most adults with the type of motor design we're going to make. And it actually will rotate and will work. So it's going to be super fun. Now, if you know of anybody who would love to have this kind of learning in their home environment, please share this video with anybody you think would be excited to learn real hands-on science. I put in the description the links to all the free classes that we are doing right now, so you can have those easily as well. Okay, any other questions? Does Radioshack still exist? No, I forgot to finish that story. No, sadly it doesn't. We actually, when Radioshack went out of business, we bought as many of their, we bought several thousand, I believe, of their electronic learning labs to be used with our programs and stuff because they were so good. Unfortunately, they're not in existence. The company now actually that we recommend you buy from is Jameco, and those are all the links that are in the description for this video. Radioshack does have a website, that is true, but we found their stock is really limited in what they carry and what's available. If you are into big quantities, like tens of thousands of things or hundreds of thousands, then you're going to go to a big supplier like Mouser or DigiKey, who has absolutely everything ever manufactured electronically on the planet. Their catalogs are huge though, so it can be really scary to navigate. Okay, any other questions that are coming through? You love the hexagon box. Yeah, isn't that fun? I made that, it's got a date on it, 2004. So, okay. Can you use fishing wire for the trip thingy? Absolutely. You can use anything that is invisible. I have some invisible nylon thread. It's actually real thread you'd like put in a sewing machine, and so that works really well because it's like a human hair, but it's really, really thin, super thin. How to make the air horn. I've had several parents say, please do not teach my child the air horn. So I'll say this. If you want to make the air horn, it's on our program in eScience. I can't stop you there. It's in Unit 6. It uses a balloon and an M&M film can and a straw, and it is super loud. Maybe I'll show you later. Okay, I don't want to get you in trouble. I don't want to get me in trouble. I want you to come out here and hang out with me so we can do more science. Okay, other questions? Questions? Will this be recorded? Yes. Sorry about losing audio before. That was totally my fault. Let me show you where you can find the recording. It is, oh yes, it's in Antarctica. No, it's not. It's, here, let me show you where it is. It's in Facebook here, and it takes a long old time to pull this page up, I know. And then you simply click videos. You see that right there? You just click on videos, and then you will be able to see the videos that we have been doing. As soon as we're done, this video will pop up and be under latest videos. I've been trying to also include, a number of people have asked for our math content, so I've been posting math content every day. I hope it's been really interesting and fun for your family. Okay, if you have questions, I'm Aurora at superchargedscience.com. This website at the bottom, if you want to join me, there's more information on how you can enroll in that program as well. I look forward to seeing you tomorrow. We're going to make DC motors. I will remind me to talk about batteries because I might forget. But I'll see if I can pull apart a battery so I can show you so you don't have to do it at home because it's not really a safe thing to do. All right, I will see you guys tomorrow. Go do your burglar alarms. Show me pictures. Tell me what happens. Type it in the comments. And I want to hear about what you've actually been doing. Feel free to post, send me pictures and tell me it's okay to post, and then I'll post them with this video so other kids can see what you have done. I will see you guys next time. Take care, everybody.